Hi guys, today we are going to do the Ion ID lab together. So our objective in this lab is to be able to analyze an unknown solution, which I have here in my beaker, for the presence of cations and anions. Now we're going to do it in somewhat of a station lab where we'll do 5 individual tests to see whether or not our unknown solution has any of the cations or anions that we're looking for. Now, in order to know, we're using what's known as a positive control. So at each station, there's going to be one solution that we test that has the ion we're looking for in it, so that you can see what happens when that ion is present, and then compare the known solution with our unknown to see if the unknown also has that ion at the end of our lab. So let's get started.
All right, so we're going to go right down the procedure, and step 1 actually has us preparing a hot water bath for use later. So what I've done is I've got my tap water just in my beaker, and I'm going to stick it on the hot plate, which is behind me, and heat it up so that we can use it later. Work smarter, not harder. Okay. So then that brings me to step 2, where I have already washed the test tubes and rinsed them with deionized water. Now it's going to be really important that I use deionized water because we are testing for ions. And as the name implies, deionized has all of those ions removed. So by rinsing everything with deionized water, that means that any residue that might be there from our tap water will be gone, so that our tests are true tests. So I have already done that and prepped the test tubes for us. So now I'm going to be completing step 3, which is all about station 1. And we are testing for the chloride anion. So chloride -1 is what we're looking for. And I'm going to be using a pipette to add 1 milliliter of sodium chloride solution to my first test tube. Not sure how well this is going to come out, but on my pipettes there is a little raised line right about here, and that is 1 milliliter. So I can use my pipette itself as a measuring device for very small amounts. So that's what I'm going to do. So I'm going to take my sodium chloride solution and measure 1 milliliter and add it to my test tube. So this is my known solution. I know that this solution has the chloride ion in it, so it's going to be my positive control. It's going to tell me what should I expect to see if chloride is in our unknown. Okay. Continuing in the procedure, I'm now going to add my 1 milliliter of unknown solution to our second test tube. And now I'm going to add 5 drops of 1 molar nitric acid. So my nitric acid is in a dropper bottle, which makes it nice. And I'm going to be adding this to both test tubes because this is going to be part of the reaction that I'm looking for. So 5 drops. And my procedure now tells me to add 5 drops of silver nitrate solution. So I'm going to do that. All right. So as you can see in the test tubes, we have a big color change. So this test tube here had my known solution. You can see that it has gone white. So that means that a white color change is proof positive that the chloride anion is present. So if we take a look at our unknown, we have that same white color change. So go ahead and record your data. All right, so now we're going to move on to station 2, and I've zoomed in the camera because it's going to be really important that you take observations as I'm adding the acid in this station, okay? So according to my procedure, we are testing for the hydrogen carbonate anion. So I'm going to be adding 1 milliliter of sodium hydrogen carbonate to our first test tube. And I'm measuring it just like we did last time with a new pipette, because we don't want to cross-contaminate solutions. So a new pipette is used to add the sodium hydrogen carbonate. And now I'm going to add our unknown solution to the second test tube. So 1 milliliter there. So now I'm going to add the hydrochloric acid, and again, make sure you watch carefully as I add it so that you can record your observations. So I'm going to add it first to the sodium hydrogen carbonate to see what should I expect if the hydrogen carbonate anion is present. All right. Now we'll add the hydrochloric acid to our unknown solution. Remember to watch carefully. Make sure you record your observations. Moving on to station 3, where we are going to test for the phosphate anion. So I'm going to add 1 milliliter of sodium phosphate solution to our first test tube. Now this is a dropper bottle, so it will be important to note that 10 drops is 1 milliliter. Okay. Next, we'll add 1 milliliter of our unknown to the next test tube. And now to both, I'm going to add 1 milliliter of copper 2 sulfate solution. So a new clean pipette for no cross-contamination. Measuring out the 1 milliliter. Adding to the first. And the second. So, for proof positive, we have a color change, but we also have this sticky precipitate, this gross, stringy, goopy solid in the bottom of this test tube. Whereas in our unknown, we have a slight color change, but none of that goopy precipitate. So what do you think that means? Record your observations. Let's take a look at station 4, where we are testing for the iron 3 cation. So I'm going to be using iron 3 chloride in our first test tube. And again, it's a dropper bottle, so we're counting out 10 drops for 1 milliliter. And 1 milliliter of our unknown. Now, according to the procedure, I'm going to add 3 drops of hydrochloric acid to each. And lastly, to each test tube, my procedure says we need to add 3 drops of potassium thiocyanate. All right, so our positive control, make sure you take some good observations there, and our unknown, make sure you record your observations there as well. Station number 5, we are testing for the magnesium cation. So we're going to be adding 1 milliliter of magnesium nitrate to our first test tube. Now our unknown goes in the second. And now, according to my procedure, I'm going to add 1 milliliter of sodium silicate to each test tube. All right, so our positive control, and our unknown. Record your observations. And now here we are at station 6. I think I miscounted at the beginning and said 5 stations, but surprise, we have 6. So here in station 6, we are going to test for our calcium cation. So I'm going to add 1 milliliter of calcium nitrate solution to our first test tube. Clean pipette. Measure out 1 milliliter. And our unknown will go in the second as always. Now I'm going to be adding 5 drops of sodium oxalate to each test tube. Okay. So maybe you can take some intermediate observations. But according to our procedure, we are going to place these into the warm water bath that we set up at the beginning. So you can see, I'll turn my camera, that our hot plate is functional, and we've got our water from the beginning of the video up there, and he's nice and hot now, but not boiling. That is important. This is a hot water bath, not a boiling water bath. So I am going to take my 2 test tubes and place them into the water. So before, this is our positive control. And our unknown. And we're going to let those heat up for just a few minutes. So through the magic of editing, you will see the results momentarily. Okay, I waited a few minutes for our test tubes to be in the warm water bath. And hot glass looks the same as cold glass a lot of the times. Here we can see some condensation along the sides, but I'm definitely not picking those up with my hand. So I have my test tube tongs here to save my fingers. Safety first, kids. And what I did not mention before was that I did mark these test tubes so I would know which one was which. So The positive control has the black line on it. So after a few minutes in the warm water bath, what we find, hard to tell with the camera, is that the precipitate is crystallizing along the bottom. So originally it was just floating powder-like throughout the whole solution, but now we're seeing some separation as those powder and crystals come together. So now let's take a look at our unknown. I think you can probably see it a little bit more with the unknown, how they came together really nicely. So make sure you record your observations in your data table. Follow up with your teachers if you have any further questions, and make sure you take care of the analysis at the end.